From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan, announcing show number 198, recorded live Thursday, January 14th, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks about the Reactive Framework and link to events with Erik Meijer.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm here on the Microsoft campus in Redmond, Washington in Building 35, and I have the distinct pleasure of sitting down today with Erik Meijer. How are you, sir?
I'm very good, thank you.
Now, we're sitting here in Building 35 in the Cloud Programmability group, is that correct?
Yes, my team is called the Cloud Programmability Team. And we're focusing on making it kind of, another way I say it is like democratizing the cloud.
Democratizing the cloud. Well, wow, and you have a lot of black squares that are actually stacked up on your wall here. These are all patent cubes?
That's correct. So yeah, that's one of my hobbies, to collect patents, to write patents. When I was, before I came to Microsoft, I was a professor, and as a professor, you write research papers. And so now, when I came to Microsoft, in the product team, you don't write research papers. So I kind of substituted that with, patents.
Well, it's ever so, imposing to notice that you've, basically used them as wallpaper.
Yeah.
So
yeah. My goal is to kind of, fill the whole window here.
Well, you've definitely made your point. One of the things that I wanted to come and talk to you about is this notion of the reactive framework. I've heard people refer to it colloquially as things like link to events. But I want to start at the beginning because I think that the listeners understand link to objects. I think most of our listeners understand the basics of IEnumerable. But if you wouldn't mind talking to me like I'm a 4-year-old, C# or VB programmer, and then let's move our way up to programming the cloud.
Okay, no problem. So yeah, everybody is familiar with link to objects. That's the kind of workhorse of the .NET framework. And if you look at IEnumerable, it is an interface that many collections implement. So for example, arrays, lists, hash tables, they all implement the IEnumerable interface. And the IEnumerable interface is a pool interface. So if you have a collection that implements IEnumerable, let's call that the producer, then the consumer asks the producer to get the next element. So you say move next, or first you say get enumerator,
right,
which gives you a handle to enumerate the elements of the collection. And then whenever you want to have the next element, you say move next, which causes the producer to create or produce the next element. But as the consumer, you're blocked. So you're pulling, but you're blocked until the producer hands you the next element.
Okay.
And then once move next returns true, then the value is available in current.
Does that mean that as someone who might implement that interface, I could write a poorly behaved implementation of IEnumerable such that I am blocking all callers or at least making them slow?
Yes. For example, when you use iterators, the things that have yield return. So you might write something that returns an IEnumerable of int, where you never reach the yield return, or, it might take, you do a thread.sleep, of an hour.
Right.
So, and that means that now the producer is kind of dependent on the collaboration of the producer to get those values.
Well, I think that as the programmer, the consumer of those values has an assumption, just like there are assumptions at the method and property level. When I call a method, I expect it'll take a little while. If I call a property, while it's possible that underneath the get is a lot of evil and a sleep for an hour, there's an implicit contract that methods take time and properties don't. And I think that amongst those that that consume, in a for each loop, that it's going to be pretty fast.
Yes. But let me give you an example, of like in .NET 4.0, when you read files or directory, that now returns an IEnumerable of files or
file info. Yeah.
File info. Yes. But depending on your disk speed and so on, that might take a long time. So really, there's a lot of latency in that call. So instead of blocking And instead of like pulling the data from the producer, you might be better off to kind of, be notified whenever the producer has a value available. And that kind of push model is something that we're all familiar about as well. Because if you write a UI application, you're not asking a button, give me your next click. But when the button has a next click, it will call you back.
Exactly.
So the button has a kind of push model.
But I think that the perception in the past and is that that's slow, that events by their nature are slow. And that may be just apocryphal. It may just be perception, but that sense of, if I ask you, I want it now. If I count on you to tell me, it's going to take a while for that message to get back. So I think that people would intuitively, and perhaps wrongly, think that that kind of a model would be slow.
But I think that's not really relevant, right? Because whether it's slow or fast, it's really a way to decouple the speed from the producer and the speed of the consumer, right? With enumerable, I, as the consumer, now kind of, depend on the speed of the producer. So I cannot proceed until the producer proceeds. Whereas with the push model, with events,
right,
I can do stuff while, somebody else presses the button. I'm not blocked on that. And this is the same why when you're doing, say in Silverlight, when you're making service calls, there, you make the call and you get an event when the call returns, or you use the begin invoke, end invoke pattern. There you also use this push model because you want to decouple your progress from the progress of this other operation.
So what is the difference in that versus maybe a poor man's implementation, in the sense of a lot of people are used to spinning off another thread in order to go and pull data, and they may feel that they've solved the problem by simply letting another thread worry about it.
That's fine, because when you let another thread worry about that, that's kind of an implementation detail. But now you still have to create a mechanism how that other thread signals to you when it's done. And again, like the .NET begin invoke, end invoke pattern is a good example, because it gives you two ways to deal with that. One way is you can give a callback to the begin, right, that will be called when it's done, or you can block on the async result. Right. So it allows you to both kind of, block or get called back.
Right.
And so what I'm trying to do with the Reactive Framework is to kind of separate and formalize both these models. So the push model, or so the pull model, is already formalized with the enumerable.
Right.
So if you have a source that you pull values from, that source implements IEnumerable. But we don't have anything that formalizes the push model. So if I have a source that pushes stuff at me, what is the interface for that? So that I can have multiple types that implement that source, such that just like with enumerable, I can write libraries that only depend on the interface, but not on the actual type.
Okay. So does that, and I've read up on this a little bit, this is then the mathematical dual to link to objects.
Yes. So the mechanism at which we designed the interface, we're using this trick of mathematical duality. But that sounds really scary. It sounds
like I need a PhD to understand.
Exactly. And that's not true at all. So let's go back to the simple example of a button.
Excellent.
Okay. Now look at a button. What is a button? In my opinion, a button is really a collection. It's a collection of clicks.
Potential clicks.
Yes. Well, no, but it's really a click, because if
I
click, you get the click events, right? So in some sense, it's a collection, but it's not a collection that you pull from, but it's a collection that pushes the values at you.
And it doesn't really matter that I don't know how many there are or that it never ends.
No, because it's just a collection. Yes. And so, like in my talks, I often use coins. Okay. And here let's do some old school radio.
We got a bag of pennies here. All right.
Yep. And now you can visualize, and my math teacher always said, if you want to explain something, explain it with money.
All right, let's see how we're going to use the money then.
So, let's start with the pull model. So the pull model is, so you are the, Scott here
I'm
holds
the button.
the money.
I'm going to hold the money here.
And he's the collection. And now I have to ask Scott move next.
Okay.
And now Scott, of course, is kind of teasing me, and he's not giving me the money.
Yeah.
He's letting me wait. So now he gave me one.
Okay.
And now I say move next again.
I'm thinking about it.
And he's thinking about it, and now I get the next penny.
All right.
Okay.
Makes sense.
And so I'm really begging Scott to give me the next one. That's not a nice feeling.
No, it's not.
What I rather have is I want to have the push model where I tell Scott, whenever you have a penny, just throw it at me. So push it at me.
Oh, okay.
And now look at this. Now I'm getting
Boom.
rich. It's like a jackpot in the casino, where it just, and the money comes
the old
in.
school radio and money's flying at you at this point.
Exactly. So that's kind of the difference between the pull model and the push model.
And you may well be doing other things, but you're not as much worried about waiting around for me to give you that money.
Exactly. Because while, I can just have like a cup here and I can tell you, put the money in the cup, and then I can go on and do other things.
Okay.
So that is kind of the basic idea between the push model and the pull model.
Okay.
And then what RX is basically two interfaces that represent push-based collections.
Okay.
And the push-based collections, let's go back to IEnumerable to explain how the pull collections work. So in IEnumerable, you first say get enumerator. Mm-hmm. And then when you get the enumerator, you can call move next. And then you get current. And then you call move next. And then you call current. And then move next returns false. And then you're done.
Okay.
Now let's look at how you would do a push collection. So with a push collection, you, instead of saying get enumerator, you give the push collection a callback to say whenever something happens, notify me on that thing.
Okay.
Now how do you get notified? Well, with the enumerable, you can be notified for three things. You can be notified with the value. That's when move next returns true and you say get current. Mm-hmm. You can be notified of the end of the collection. That's when move next returns false. Mm-hmm. Or it can throw an exception. Many people don't realize that, but if I call move next, that might throw an exception. Okay, so there are three possibilities.
Okay.
There's three possible values: a normal value, mm-hmm. termination, or an exception.
Okay.
Now the same thing in the push-based collection. When I hand you this interface, you can tell me three things. You can give me a normal value like a coin. Mm-hmm. You can tell me I ran out of money, don't mm-hmm. expect anything more. Or you can send me an exception and say something went wrong.
I've had a heart attack. There's no money.
Exactly.
I'm unavailable.
And so that's what we call the observer interface, which is something that has three functions: on next, which gets the regular value, on completed, that indicates termination, and on error, where you send me an exception. Okay.
Now, for the listeners who have been thinking about this and been listening along with us, they may be saying, well, I've never personally called get enumerator. I've never really thought about IEnumerator, IEnumerable. They've been viewing that through the lens of for each. They've been viewing that through the lens of select and link.
Exactly.
The DSL, that is link, has been hiding the fact that this is really happening.
Exactly. And so for we do exactly the same with RX. Just like you hide the whole mechanism of, get enumerator, move next in for each, or in particular now with link in where, select many, group by, all the sequence operators, and you can write link queries over those. We have this implemented exactly the same operators on these observable collections. And observable collections is maybe confusing because there's also the observable collections in WPF, but on these observable collections, there are these push collections.
So to be clear, what we know of as observable collections in WPF are not observable collections as it relates to the
Although they
Reactive
could
framework.
implement observable.
Oh, I hope they do.
They signal an event whenever something changes, which is like, every event you can view as an observable.
Okay.
So we have implemented all the link operators over these IObservable based collections, and that's why sometimes people call this link to events, because an event stream, like a button clicks, is an example of something that is a push based collection. Now the nice thing is that you can write very compositional things now using link queries that you couldn't do before. Imagine that you want to write everybody's familiar with this in Visual Studio. When you have IntelliSense, whenever you type something, IntelliSense doesn't show up immediately. Right? Only when you pause for a little while, then IntelliSense shows up. Otherwise, it would drive you crazy, right? You type and then IntelliSense would go up and down. Mm-hmm. So it kind of pauses, and then, so when you pause for a little bit, IntelliSense shows up. Mm-hmm. Well, that's now an operation that I can define on any event stream. So imagine that I have a button in my UI, and if you click on it really fast, I don't want to call an action whenever you click on the button, right. Only when you click on the button, and then there is no click within a certain time period.
Hey everybody, this is Scott coming at you from another place and time. No doubt you probably bump into testing tasks now and then in your work. And writing functional tests is probably not your favorite thing. It's kind of difficult, takes time, and the results can be dubious. Well, get ready to start liking tests thanks to Telerik with the new WebI testing framework. Building web automation tests is a breeze. You've got code automation with advanced ASP.NET Ajax and Silverlight applications. You can write a single test, have it executed against multiple browsers at once. You benefit from a rich API. There's link support, integration with Visual Studio unit testing, also NUnit, XUnit, and MBUnit. Not to mention the free wrappers for Telerik RAD controls for ASP.NET Ajax and Silverlight, all shipping with Telerik's new testing tool. One of the best features, the WebI testing framework, which is developed by Art of Test, is it's absolutely free. If you've already got hooked on WebI testing framework, start using it right away. Go to Telerik.com for more info. Thanks a lot. Right, that's the kind of thing where that would be kind of difficult. I think I'd make a timer and I'd keep a track of how long it's been, and and I think it would probably take a little thought, 8 or 9 lines of yuck, and might have some race conditions and some weird behavior.
Plus, if you now want to do that for a key up event, you would have to write everything again. You would have to copy and paste that
whole
code.
State machine.
Exactly. And so what we now can do, if you expose your events using an iObservable, then you can reuse that same library that we wrote to do that and apply that to any event source. Another interesting.
Before you move on, can you say a little something about what that syntax might look like? Because I'm familiar with from P in people, that kind of. What is this?
It's exactly the same thing. So and let me try a little bit experiment. This is like hard to explain in words, but my old professor told me if you cannot explain it in white ink, you cannot explain it at all. So I'm explaining it in white ink, which is words. Let's look at a simple example of an Ajax application. An Ajax application usually does the following. There's some UI, and based on a UI event like a key press or a button click, you're making a service call to some web service, which might take time. And imagine you're using a service reference that returns an event. The result comes back, and then you want to update the UI. Okay, so here's how you would write this using LINQ. You say from value in UI event, from result in service call based on the result of the UI event, select the result of the service call. So you have a little query that joins the stream of UI events with the stream of service reference results. And I see your head here exploding.
My head just exploded and it's leaking onto your floor. So you've just taken what would have been the hooking up of an event handler, which would be one line of code up off somewhere in the top of my file, the event handler itself, the method call, the stuff that I would have to react to. I'd have to dig it out of the property, the parameters, and you've distilled it down into one terse but readable single line of code, which is essentially what LINQ does.
Yes, exactly. And the nice thing, and this is really the power of LINQ. I think we're still underestimating the power of LINQ, because a lot of people, when they hear LINQ, they think maybe LINQ to objects and maybe LINQ to SQL or LINQ to entities. But LINQ can work on anything that implements the sequence operators. And in this case, these push collections also implement the sequence operators, so you can write LINQ queries over them.
So all the pushing, all the announcing, all the threads, all the synchronization, all the event throwing is hidden entirely
inside the sequence operators.
Operators.
Yes. And so you can do that once and for all. And so we are spending a lot of time, and when you came in, you saw that I was kind of talking with my team. We're spending a lot of time making these things correct, and especially the edge cases, and race conditions and so on, and such that, you can then freely compose these kind of simple building blocks in bigger ones.
And what about wheres? Like, when would I use a where or a filter of some kind?
Here's an example. Suppose you have your mouse and you want to restrict your mouse to stay within a certain window in your screen.
I was doing this
box.
Just last week. I was doing this.
Well, so what you do is you take your mouse moves and you just say where X position is less than within the boundaries, and the Y position is within the boundaries, and now you only get events from the mouse within. So
window. You're actually you're actually filtering the creation of event. You're saying I don't even want to know about the event
exactly
if it doesn't meet this.
Yes,
because this is such a classic problem, and I always get nailed with the I'm trying to drag something and I didn't think about the mouse move with the mouse button down is different than when it's up.
Yes.
And that's the best way to crash a new program that does a lot of drag drop is to grab something and just start shaking the mouse around and see whether or not they're off. They have an off by 1 pixel or negatives. Move it onto another monitor. Change different coordinate system.
Yeah, and so
that's a lot of code.
Yes. And funny that you mentioned it. Drag and drop is one of kind of our famous examples, and it's like also an exercise, and it's incredible in how many ways you can actually write drag and drop using Rx. And if you go to our forum, or I think there's also an example in the 101 Rx samples to do that. Talking about kind of writing UI programs, a lot of people think that when you're writing UI programs, they are hard to test, because for example, I have to test your program that does drag and drop, because how do you test that? Because you have to maybe have a real mouse to move, right? Because, how do I simulate my mouse? How do I write a mock mouse stream? Well, if you use Rx, it becomes trivial, because what you can do is you can replace the implementation, the source of the mouse move events, by something else, say an array.
Just a collection. Just a collection of events, yeah.
And then you say to enumerable on that array. So that's your input. And then you can look at the output stream, turn that into another array back, and then you can just compare that to the expected outputs.
I don't need a mock mouse, because all I was reacting to before were events that were in a collection. I just simply make that collection and pass it in, and the data is the data.
Exactly. So by making events first class, you allow to kind of plug in a different implementation. And that's kind of one of the big sources of power of the reactive extensions. Events in .NET are beautiful things, but they are not first class. And what do I mean by first class is that you cannot take an event and put it in an array, or you cannot take an event and pass it as a parameter or return it from a method.
Right.
An event is kind of tied to the class in which it's declared. What we do with Rx is we free events from the prison of the class. And now events become first class things that you can put in an array, pass around, and now it becomes really easy to create a mock source of events, because it's just like any other type.
And by including them into the link ecosystem, just as they are as first class as system.object, right?
Yes.
Whether I'm looking at events or XML or SQL or file systems.
Yeah.
It's all what I'm comfortable with already.
Yeah.
How do we get into this now? Help me understand the state of the project. Where is it? What's the ship vehicle? How do I get it? The listeners will be interested in this. Where can they use it, and where do you think it's going?
Okay, so that's a good question. So the interfaces, the two interfaces, iObserver and iObservable, are shipping in .NET 4.0. So there you can get them.
And they're inside of system.core?
They are in System Reactive.
System Reactive, okay.
Or System Observable. That's the
namespace, but they're probably in the system.core physical deal, though.
Yes. So sorry. Yes. I'm here confused because we have like many versions that I will explain now.
Okay, good.
So the interfaces are in .NET 4.0.
Yes.
And the reason I sound a little bit confused here, because in .NET 4.0 we introduced something really beautiful, which is co and contra variants.
Mm-hmm.
And since these are interfaces, they are co and contra variant. The observable is covariant and the observer is contravariant.
So you might want to take a moment, because a lot of our listeners don't necessarily speak English as their native language, and they're going to be off looking this up, and they may or may not be familiar with the terms of covariance and contravariance. So if you just take a brief moment.
Okay, so what covariance means, and many people that have used collections in .NET will have discovered that. Let's go back to arrays. If I have an array of bananas, I can pass that where you need an array of fruit. Because fruit is a subtype, bananas is a subtype of fruit. So if I have an array of bananas and you need an array of fruit, I can pass you that array. Now, if you expect an enumerable of fruit, I cannot pass you an enumerable of bananas, because enumerable until .NET 4 was not covariant. So the fact that, even though banana is a special kind of fruit, an enumerable of banana was not an enumerable of fruit.
So this was basically another way to phrase it is that array, as simple as it is, was a first-class citizen, and enumerable was not a first-class citizen.
And in some sense, it's more not that it's a first-class citizen, but it's the fact that it's a generic type that has a type parameter, but the subtyping, the inheritance relation, is not carried across the generics.
Okay, so then now the beautiful thing that you've added in .NET 4 because of that is the ability to do this with events?
Yes. So that's why we have that in .NET 4.0. But now when we backported the Reactive Framework to 3.5, there is no covariance there, or there is covariance, but C# 3 doesn't expose that. So we have a separate implementation for that. Then we have a separate implementation for Silverlight and a separate implementation for the compact framework. So if you go to DevLabs, you asked about shipping vehicle. So on DevLabs, we have installers available with the full framework for each of these platforms, each of these versions of .NET. And so they're all kind of slightly different. Another interesting aspect here is that in RX, you mentioned a while back that if you want to do something asynchronously, you spin up a separate thread.
Right.
In .NET 4.0, we introduced the TPL, the
Task Parallel Library.
Task Parallel Library. And so we said, well, in case you need to introduce concurrency, why aren't we leveraging, the TPL? So RX is built on top of the TPL. But in 3.5, there is no TPL. So we worked together with the PFX team and backported the
PFX
TPL.
Is the Parallel Framework Extension.
Yes.
Yeah.
And we backported that to 3.5. So if you download RX from DevLabs, you get an implementation of the parallel framework for .NET 3.5.
All right. So let me see if I understand this, because if I understand it, I'll be able to say it back to you.
Good.
So the Reactive Framework and the interfaces that support it are in .NET 4.
Yep.
And when .NET 4 ships, they'll have that.
Yep.
They can go up and get implementations for Silverlight, implementations for Compact Framework, and implementations for those are the two primary things, Silverlight and Compact Framework?
No, Silverlight, Compact Framework 3.5.
Okay.
And for 4.0, the implementation of the sequence operators, because in 4.0, it's only the interfaces that are there.
Right. Now and that'll be supported because it's in 4.0.
Yes.
The backport to 3.5 is still a labs thing, or is it fully supported?
It's on labs, but we're kind of, what does fully supported mean?
Well, I guess what I'm saying is if I'm a big corporate developer and I'm going to go tell my boss I should use this, would he be more happy if I use the 4.0 version than if I use the backported 3.5 version?
To be clear, the 4.0 version only the interfaces are in the BCL.
Right.
The sequence operators are on DevLabs.
Right.
Now, talking about can I use this? We have a very liberal license.
Oh, good.
Where you can use this. So it's kind of different than in the BCL. But if you read the license, the way I think of it is that we're trying to take away all the barriers for people to use RX.
Okay, so no one should be afraid of using this. It's not a skunkworks thing. It's a real thing with a team behind it.
Yes.
Okay. Now, interestingly, at the beginning here, you're in the Cloud Programmability Team, and we haven't said anything about the cloud. So how does all this, what we've just talked about, fit into the cloud?
Well, so the cloud is all about, let's say, what is the best way to say it? The way I look at the cloud is that it's mashing up services from different sources into a client. Now, all these services, to get to them, is an asynchronous call. You have to go across the network and make an asynchronous call. Now, on the client, you have to synchronize and orchestrate these different services. Which is also an aspect that we haven't talked about, but which is very important. Imagine that I'm making 2 service calls, or 3, to 3 different translation engines.
Okay.
And now I want to wait until 2 out of 3 have returned a result.
That's a classic kind of a problem. That's the kind of thing where the businessman, the suit that signs my checks, can say it very easily. Hey, programmer, call these 3. 2 out of 3 within 5 seconds, and then use them. The third one doesn't come back, don't worry about it. If only one comes back, give up and show an error. And he'll say, that was crystal clear. And you're going to think, all right, well, that's about 60 hours of work.
Exactly. And with RX, that should become easier. That's when I mentioned in the beginning, democratizing the cloud. Those are the kind of scenarios that I want to make super, super easy. Mm-hmm. So one of the things that's also in RX is something called the joint patterns, mm-hmm. where you can write rules. Think of like Outlook rules that you have in your inbox. You know, if a message comes in the inbox and it satisfies these things, then put it here. Mm-hmm. You can write the same rules on event streams or on asynchronous computation. So if these 2 come in, you do this. If these 2 come in, you do that. And so you can write at a very high level, you can write very concise synchronization logic mm-hmm. to orchestrate service calls and event streams, etc.
You know, and having little kind of like firecrackers going off in my head, because I'm starting to realize that it makes total sense why you would be working so closely with the PFX team, with the parallel team, because they are democratizing multiprocessor and threading. They're trying to make concurrency accessible, as are you. You're
yes.
trying to make this kind of concurrency accessible.
Yes. And for example, here's a concrete example. If you take a task, you can take a task and turn that into an observable. So, if you have any API that works with tasks, you can expose that as an iObservable. Mm-hmm. And in some sense, that's comparable to taking an array and viewing that as an IEnumerable. So a task has a lot of special properties and special operations. Mm-hmm. But now I want to glue together a task with, button clicks. And that is what RX allows you to do, because you can express both in terms of this higher level interface.
This is really interesting. I'm starting to realize that looking at the way that you've integrated with Link, the way that the parallel extension teams are integrated with Link, that you're going to be able to write very, very clear and crisp statements that'll say things like, fire off these services when these come back, go off in these cores and use, 4 out of the 8 available cores to process this information. Let me know when it's done. And it starts to, the code you write starts to look more like what the businessman in the suit actually said.
Yes, exactly. And that's kind of the whole point of Link, where you kind of, you're raising the level of abstraction, where you can write these things in a much higher level way without, where you abstract again. And we mentioned this notion of abstraction a couple of times, right? All the complicated locking and so on is now hidden in the sequence operators, mm-hmm. such that you as a programmer only have to, it's like Lego blocks. You can kind of now connect these together. And then inside these blocks, there's a lot of complexity, but that's all hidden for you.
Well, and this is one of the things that I've been saying, kind of more and more. And I feel a little bit like you're validating what I've said, which is in .NET 4.0, and I'm going to sound like a fanboy here of my own company. The Lego blocks are the right size. Before, it was like the little tiny one-piece Legos and then the big ones that you give to your 2-year-old child and you try to make them work together, and it doesn't. But I feel like more than ever that Lego blocks are the appropriate size for most of the business problems that I'm trying to solve.
Yep. And I would agree with that. And so we're writing a lot of samples, and even though, and as you say, even though, I made this myself, it surprises me every day when I write a sample how beautiful and how elegant you can describe problems. It's like you think, okay, here's a problem, and you scratch your head a little bit, and then, oh, this is, it's like a little poem that, your code is like a poem, and it makes programming a lot of fun when your code looks beautiful and kind of tight and does exactly what it needs to do without any kind of noise. That's kind of what, gives me pleasure in life as a developer.
Well, that's fantastic. Well, Erik Meijer, thank you so much for sitting down with me today and sharing this framework with me.
You're very welcome.
We'll put the links up on the show site that you have access to all of this stuff, and maybe we'll come and see Erik again sometime. This has been another episode of Hansel Minutes, and I'll see you again next week.